Rocklin Thunder Physics presents pulley sample number 1. Rocklin Thunder Physics, where 91% of AP Physics students pass the AP Physics exam. We'd like to thank our friends at Pasco Scientific, James Jackson at Modeling Physics, Webassign.net, and our friends Dr. Peggy Bertrand, Gardner Friedlander, and Martin Kirby. These are some of the forces you should already know: the force due to gravity, the normal force, the force of tension, the applied force, static frictional force, the kinetic frictional force, and the drag force. Working second law problems, you should already know that step 1 is to draw a force diagram and a motion map. Necessary, draw a component diagram, and also, if necessary, to rotate the axis. You're to explicitly write F equals ma. Now this is really important. You'll get credit just for writing F is equal to ma. The sum of the forces is equal to ma, I should say. You should write out Newton's second law in the horizontal and vertical directions. And finally, substitute numeric values where appropriate and solve for unknown. This is a sample problem of accelerating blocks. In this sample problem, we're asked to derive an expression for the acceleration due to gravity of the system below and for the tension in the string. So step 1 is always to draw a force diagram. So let's draw a force diagram of M1 first. We notice that it's got a force due to gravity, which is straight down. We also notice that it has a normal force from the surface pushing up that we'll label the normal force, and a force of tension pulling it to the right. We'll also notice that for M2, its force diagram has a force pulling it downward with a force that we'll label Fg2, and that reminds me I should label this for M1 Fg1. They're different weights, so therefore different forces due to gravity. I should label that Fg1 and distinguish that from Fg2. Now there's also going to be a force of tension pulling upward. This force of tension pulling upward is going to be equal to this force of tension because it's the same string. So we're noticing that this horizontal force is going to be somehow related to these vertical forces. Step 2 is to draw a force diagram with components. Because none of our forces are off axis, we can skip step 2. So we've completed step 1, which is to draw a force diagram. We skip step 2 because we have no off axis vectors. We go on to step 3, which is to explicitly state Newton's second law. And Newton's second law says the sum of the forces equals the mass times acceleration. So let's write in step 4 the Newton's second law equations for both M1 and M2. So if we look first of all in the horizontal for M1, we've got Ft, the sum of the forces in the x direction should equal the mass times acceleration in the x direction. So in the horizontal, I'm going to get for M1, Ft is going to equal m1 times the acceleration in the horizontal. In the vertical, I've got an equation of Fy is equal to may. And I've got two forces for M1. I've got the normal force pointing upward, which is going to be positive, minus the force due to gravity, which is pulling downward. So I'm going to subtract that, and the negative shows that it's pulling downward. And that's going to equal may. In the vertical for M2, I can write an equation that says the sum of the forces in the y are going to equal m times a in the y, which in this case is Ft minus Fg2 is going to equal the mass m2 times the acceleration. Now what I'm going to do is I'm going to look specifically at two equations. I'm going to look at this equation and I'm going to look at this equation. The reason I'm going to do that is that these two equations have forces of tension that connect each other. So since the string is connected there, this force of tension that's pulling upward on M2 is going to equal the force of tension on M1 that's pulling it to the right. So these forces of tension are equal to each other. So what I will now do is I'm going to take this force of tension, the M1A, and substitute it into F sub t. So let's use a different colored pen to show that. So I'm going to take this Ft and I'm going to plug it into there. And I'm going to rewrite this equation up here. I'll write it as M1A minus Fg2 is equal to M2A. Now notice in the original equations I left that acceleration and that acceleration without subscripts because I want to show that they're the same acceleration. These two objects are going to experience similar accelerations. One of the things I also have to do is I have to go back and notice that I left something out. In this equation, the acceleration is pointed downward. So I want to actually put this as a negative sign there, and that's M2 times negative A, because this acceleration again for M2 is downward. So what that means is I'm missing a negative sign here. So let's erase this and let's include our negative sign. I'm going to pull this negative sign out and I'm going to set it up right there. And I'm going to say that this M1A is equal to negative F sub G2. And I'm saying it's equal to negative M2A. So all I've done there is I've taken the negative sign out of here and put it in the front of these two products. So now I've got M1A. I know that G2 is equal to the mass of object 2 times the force due to gravity, and that's equal to minus M2A. I want to solve this for acceleration, so I want to have all the accelerations on the same side, and just to skip a step, I'm going to move this this product M2G over to the other side. So I'm going to add M2A to this side and add M2G to the other side. So that means I'll have M1A plus M2A equal to M2G. I'll factor here, so I'll have A times M1 plus M2 equaling M2G, and then I'll divide both sides by M1 plus M2, so my acceleration will be M2G over M1 plus M2. So that gives me my acceleration. Now it also asks for the tension in the string. So let me get a different color here to distinguish between this new problem. I can use either of these equations, either this Ft equation or this Ft equation. I'm going to choose the first one because it looks a little easier. So in that equation it says Ft is equal to M1 times A. Now I know what the acceleration is, so I'm just simply going to take that, I'm going to plug it into there, and my equation will be Ft is equal to M1 times M2G all over M1 plus M2. And that will be my equation for the force of tension.